What is tokenization in large language models, LLMs? Imagine trying to teach a robot to understand and talk like a human. It needs to break down the endless stream of words into manageable pieces. That's where tokenization comes in. It's like chopping up a big puzzle into smaller, easier-to-handle pieces so the robot can see the picture clearly. In the world of large language models, which are a type of artificial intelligence that learns from huge amounts of text, tokenization is the first step. These models don't read sentences the way humans do. Instead, they work with smaller chunks called tokens. Tokens can be entire words, parts of words, individual characters, or even punctuation marks. There are different ways to do tokenization. One common method is word tokenization, where the text is split into separate words based on spaces or punctuation. This is simple but can cause problems with words the model has never seen before or misspelled words. Another way is character tokenization, where each letter or symbol becomes a token. This reduces the number of different tokens but makes the process slower because there are more tokens to handle. The most popular method is subword tokenization. It divides words into smaller pieces that still carry meaning, like prefixes or suffixes. For example, the word unhappy might be split into un and happy. This helps the model understand new words by combining familiar parts. Byte-Pair Encoding is a common technique used for subword tokenization, especially in models like GPT. Tokenization is super important because it affects how well the model understands language. Smaller tokens help the model handle rare or new words better. But more tokens mean more work for the computer, which can slow things down or limit how much text the model can process at once. Inside the model, each token is turned into a unique number called an id. This helps the model recognize patterns and relationships between words. For example, darkness might be split into dark and ness, sharing the suffix ness with words like brightness. This way, the model can see that these words are related in meaning. Tokenization also plays a role in making AI systems safer and more accurate. Good tokenization helps prevent mistakes and reduces the chances of the model being tricked by tricky inputs. In applications like ChatGPT, DALL-E, Midjourney, and productivity tools, tokenization helps these systems understand prompts, generate responses, and work with different languages. For example, ChatGPT uses tokenization to understand what users ask and to produce relevant answers. Image models like DALL-E break down visual data into tokens to create images from text prompts. Overall, tokenization is a key step in how large language models process language. It shapes their ability to understand, generate, and work across many different tasks and languages. Without it, these models wouldn't be able to do what they do so efficiently and accurately.